Now that you've collected all your data, you do need a way to organize that. And that's where this next part comes in with frequency distributions. So we typically organize data using two things, a table and then also some sort of visual, like a graphic, which we'll see in a little bit. So a piece of data is called a data item. And if the same data item occurs more than once, we say that the data value occurs more than once. So let's start with this example here. We're going to use this a little bit. So consider the following sample. 35 10-year-old boys were measured for height and then remeasured every year until they reached 18. The age of maximum yearly growth for each subject, so each boy, is as follows. Okay, so they looked at 35 different 10-year-old boys and they took their heights every year until they reached 18. And then when they said, they looked at each child individually and said, okay, where was their maximum year of growth, right? When did they grow the most? So this child, it was year 12, this child was year 14, this child was year 13, this child was year 14, 16, and so on. So that's what they're looking at here. So we have 35 data items here. So 35 different data points, so data items. And there are some that are repeated. So for instance, if you go through, the number 11 does occur twice. I see it here, and I see it here. So the data value of 11 occurs twice. Now, collected data can be represented using a frequency distribution, which is really just a fancy way to say table. So a lot of times if you see the word distribution, it is referring to either a table or some sort of graph, typically speaking. This type of distribution or table consists of two columns. So your data values are listed in one column, and then the frequency, so how many times they occur, is listed in the other column. And it's just a way for us to organize the data. So let's do that here with this above data. All right, so my data items are about the age of maximum growth. And then on this column, I'm going to put my frequency, which is the number of boys, right, in this case. And I'm going to actually switch pens because this is a little bit light. I want to make sure you guys can see it. So here I have the age, and here I have the frequency. All right, so what I have to do first is figure out what the minimum age is. So if I go through and look at all these numbers, I see the minimum age is 10, and the maximum age in my data is 18. So I'm going to start at 10, and then I have 11, 12, 13, 14, 15, 16, 17, and 18. Now you don't have to, I am going to draw my rows in just because it's going to help me see a little bit more organized. And of course you could do a nice table using Excel or another spreadsheet tool here. All right, and now what I'm going to do is I'm going to count up how many times that value occurs. So for number 10, I see that 10 occurs here, and that's the only one that I see. So it only occurs one time. So I'm going to write a 1 in my frequency column. Now I'm going to actually just cross that 10 out I'm going to lightly cross it out with a light color so I can still see it, but so I know I've used it. Now I'm going to do 11. So I'm going to go up here. I'm going to see how many 11s I have. I see 1 there, 1 there. So I have 2. All right, now we're going to count our 12s. So I have 1, 2, 3, 4, 5 12s. Okay, now I'm going to do our 13s. So I have 1, 2, 3, 4, 5, 6, 7 13s, and so on. So I'm going to keep counting up all my numbers. And just to save us some time, for a number of 14s, you should get 9. Number of 15s, you should get 6. 3 would be next, and then there's only 1 17 and 1 18. Now, something to note here, our total frequency in this case is 35. And so if you add these all up, I get 35, which makes sense because that is the number of data points that I had, right? So I had 35 data points. So my frequency total should be 35. It's not a perfect check, but it's nice just to make sure you probably haven't missed something, right? If you only have 34 here, then you know you're missing a data point. Or if you have too many, then again, you know you've double counted something. So it's not a perfect check, but I would add up your frequencies and make sure they do add up to your total number of data points. So this is our frequency distribution. Now, another thing you can do too, if you find it helpful, is you could reorder this right away from min to max. So that is helpful too. That'll make your frequency counts much faster. But in either case, as long as you're counting how many times each one occurs, then you're going to list them all. Now, you do want to go in order here. So I started at 10 was my smallest, 18 was my biggest, and then I listed all the ages in between. Now, I didn't have any zeros, right? All these numbers actually occurred. But if I had a value in between that did not occur in my data, I would just put a frequency of 0 there. So you do want to make sure you have your minimum value, and then you have your maximum value, and you have every value in between, even if it's not included in the data. So you need to go straight through. And then if something is missing, you would put a 0 in the frequency column. Now that worked well. Our data was pretty concise in the sense that it only went from 10 to 18, and it was helpful to look at each data point individually. Sometimes though, we like to create what's called a grouped frequency distribution. So in this case, instead of the data being organized by just one data point at a time, like 10, 11, 12, we will group them. So in the last example, maybe I want to look at ages 10 to 11. And then 12 to 13, and then 14 to 15. So you can also group your data and look at it that way instead. And that creates a grouped frequency distribution. So the data is rearranged into what are called groups or classes based on whatever we're trying to study, so whatever interests us. So for instance, grades is one that is commonly grouped, right? So your A grades would be your 90 to 100. Your B grades would be your 80 to 89. Your C grades are your 70 to 79, and so on. So we're going to consider a new data set. I have 40 students here, all with their test scores for a particular class. And we're going to use classes this time to group our data instead. All right, so we have test scores. Let's see. This is going to be our class. And then I am going to make a little column called tally, because we're going to just do tally marks to help us count. And then we're going to have our frequency, which is the number of students here with that particular score. All right, so they're telling us our classes, which is particularly nice. So my first class is 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and then 90 to 99. So what we're going to do now is just count everything up. So again, I'm going to use tally marks here to help me. So I'm going to just count however many things I have in my 40s. So you can make a tally mark for each one if you want. So there's 47, so that's 1. I'm looking for any 40s. I see another one right there. Another one. All right, so it looks like I have 3. I'm double checking my work, and I do. So we have 3 here for the 40s. Now I do the 50s. So there's 1. There's another one. Now, when making tally marks, once you get to 5, we typically make it crosswise. This would be a group of 5. So I have 5, 6 here. And we're going to do the same thing for the other groups as well. So for 60 to 69, you should have 6. For 70 to 79, you should have 11. Here we would have 9, and then you'd have 5 students who had between 90 and 99 on their test. Now, in a formal frequency distribution here, you would not include the tally column. So if you are submitting a final answer, you're usually not going to see that tally column. You'll just see the test scores and then the final answer. So the tally column you can use if you find it helpful. If you don't find it helpful, though, you don't have to use it. This is a relatively small data set, so it's actually pretty easy just to kind of go through and count the 40s and count the 50s and so on. But for larger data sets, it can get kind of tricky, so you may find the tally mark helpful. So our test scores and our frequency really what make up our table here, and we would kind of mix that tally column in a final answer. Now, a couple of things to point out here, definitions. So the leftmost number in each class is called the lower class limit. So the 40, the 50, the 60, the 70, the 80, and the 90 are all called your lower class limit. The rightmost number is called your upper class limit. So the 49, the 59, 69, 79, 89, 99. And your class width is found by subtracting consecutive lower limits or consecutive upper limits. Consecutive means in a row or in order. So for instance here, our class width is going to be 50 minus 40, which is 10, or 60 minus 50, which is 10, or 70 minus 60, which is 10, and so on. So your class width, you should see the same pattern all the way down the columns. So I can see that each change here is by 10. And I see the same thing on the upper class limits too, right? 49 to 59 is a change by 10, another change by 10, and so on. So your class width should really be the same the whole way down both of those columns, okay? Your class width is not 49 minus 40. Okay, it is not 59 minus 50. That's a very, very common mistake. So your class width is not within the class. It's going from row to row to row. So a change by 10 for each of those. So just be really careful there. So as I said, the class width should be the same all the way down the table. Occasionally we make an exception for this, sometimes with the first or last class, if we need to expand to extra data. So a great example of this could be, let's say we want to do a table on ages. Maybe our ages are 1-year-old to 10, 11 to 20, 21 to 30, again, 31 to 40, 41 to 50, and so on, 71 to 80. And then maybe the last group, instead of doing 81 to 90, 91 to 100, 101 to 110, and so on, maybe we just want to the last group, 81 and older. So a lot of times, maybe the last group in particular, sometimes the first group, we may extend a little bit to incorporate kind of more of an open-ended value. The same thing if we were doing income, right? So a lot of times maybe we would do 20,000 to 29,000, 30,000 to 39,000, 40,000 to 49,000, etc. But maybe once we get to an income of like $1 million a year, we're just going to say like $1 million plus, right? So we don't really need to break it down anymore beyond that. But in general, you should have the same class width the whole way down. Now, the table is great because that table can get transformed directly into a graph. And the most common graph we use with frequency tables would be the histograms. Now, this is a little blurry here, but I did copy it from your text. So if you go to page 778 in your text, you can see it a little bit clearer if you're having trouble reading it on the screen. So what we have here is that data that we looked at already for the age of maximum growth for the 35 boys. And you're going to see that this table correlates directly to your histogram. So notice that I see 10, 11, 12, 13, 14, and so on. And those are my tick marks along the x-axis. Those values are centered, in this case, in the bars of the histogram. So this graph is called a histogram. A histogram is a bar graph, basically where the bars are touching. So that's the most important distinction there between just a regular bar graph is in the histogram, the bars are touching. So these are used very frequently when you have a frequency distribution or frequency table. Now, your height of each bar correlates to the frequency. So notice the first frequency was 1, so the height is at 1. The next frequency was 2, so that height is at 2. The next frequency was 5, so going to the third column in, that height is at 5. Next frequency was 7, so going to the number 13 here, and I look at my height, and it is at 7 and so on. So your heights correlate directly to your frequencies. And it just gives us a nice visual display of that data. So we can see here, rather than trying to look at the numbers, we can look at the picture and say, okay, it looks like most students or most boys in this group had the biggest growth spurt at age 14, right? That's where most of your students are. There's nine boys there that had a growth spurt in the year of 14. So you can kind of get an idea of when male children, I guess, will have the biggest growth spurt, right, in their height. Probably around year 14, years 13, 15, and even 12 are also pretty large. So those are probably going to be your key years there to expect this sort of growth spurt for male children. Okay. Now, sometimes what we also do is we will draw what's called a frequency polygon based on that histogram. And you can either draw it on top of the histogram or you can draw it separately. So you can see it both ways, but this basically kind of line graph is called a frequency polygon. And it's also used to display information. So the axes are labeled just like the histogram. So you can see the same labeling here. And the points that you see here are the middle of the graphs. So it's just the frequencies. So see here for 10, your frequency was 11. This point here, your frequency was 2. Sorry, for 10, the frequency is 1, excuse me. For 11, the frequency is 2. For 12, the frequency was 5. For 13, the frequency was 7, and so on. So your points here also correlate to those frequencies. And then what you do is you just kind of put the end of the graph on the x-axis just to kind of finalize those ending and starting pieces. So you draw that frequency polygon right at the midpoint there of those bars. And that's kind of how you create it based on those frequency values. A couple other things I want to note with your graphs here. You'll see this little kind of mark. It looks like this. You zoom in on it. So that's a mark that we put on graphs to show that the axis has sort of been cut. So normally we would start at 0, right, in our axes, but here we're starting at 10 as our first value. So we use that little symbol just to show that that axis has been kind of cut and then shortened there. So we're jumping right to 10 instead of starting at 0. And it just makes our data easier to see. We don't have any data from 0 to 9, so there's no point in having all this blank space on the x-axis. Now, when you're doing your y-axis for your histograms and your frequency polygons, it is extremely important that you do not do this on your y-axis. With histograms, you do have to start at 0 there on your y-axis and have consistent counting going up to actually have those heights be correct. So with a histogram, the area of the bars also have to match the amount of data you have, right? So a larger column is related to a larger frequency. And if you cut your y-axis, it distorts the bars and makes them too short so that they're not in the right proportion to one another. So the other thing with histogram is that these bars are proportionate to one another. So they form correct ratios with the data and with the visual as well.